looking at flocculent white precipitates in a test tube? There would be a huge piece missing from my life if I continued in this field. I needed to find my way back to what had charmed me about the natural world, the creatures I could see, touch, feel, and handle, whose construction and function were beautiful. Looking back, I can see that I was trying to decide at what scale biology held the most charm for me. At the time, I saw it only as what kind of objects I wanted to deal with and where I wanted to do it. Flocculent precipitates had convinced me that my preferred scale wasn't the molecular or biochemical. This was a world of white debris, gelatinous slime, blurred bands on gels, or clear solutions that absorbed ultraviolet light. There was nothing to grasp, no form to appreciate, no movement, no behavior, not even color unless you worked on hemoglobin or vitamin B12. No one could actually see an enzyme violently clutch a substrate and wrench it and twist it until it changed chemically. The exciting things that went on in this world were constructs of the mind, built from elaborate physical and chemical measurements. My friendship with John Doyen, a graduate student in entomology, showed me a way to return to working with living creatures, not just cell-free extracts of them. John's specialty was tenebrionid beetles, a family of mostly black beetles, from tenebrous, meaning dark, with many species in the western United States. Particularly appealing was that most species produced a noxious defensive secretion that stained your fingers brown, and some of them could even spray it for distances of up to a meter. And one of them, the mealworm beetle, had even been shown to secrete a sex pheromone. Here, then, was a way to roam the western countryside to collect black beetles from under stones, collect their stinky secretion, and analyze it with the latest fancy, expensive techniques: gas chromatography, nuclear magnetic resonance, infrared spectrometry, and ultraviolet absorption. I had found a way to apply my background in organic chemistry and biochemistry, and in addition, I got to watch the defensive behavior of the beetles and dissect hundreds of them to study and draw the structure of their beautiful glands. With respect to the sex pheromone of the mealworm beetle, I figured out how to make males copulate with glass rods treated with female pheromone. What could be more fun? At the same time, I discovered the pleasures of building contraptions that aid research. I had imported a large tenebrionid beetle from Costa Rica, but the larvae in the culture refused to pupate. Seeking a cause, I eventually showed that it was the crowding in my culture that inhibited pupation. But was the inhibition chemical, mechanical, or the result of some other process? In order to test the role of larva upon larva touch, my major professor and I built a gimmick in which slowly rotating Petri dish lids dragged bathroom stopper chain over a single larva in each dish. In the controls, the stopper chain was too short to contact the larvae. The tickled larvae failed to pupate, while the untickled ones pupated quickly. This contraption, nicknamed the stimulatorium, was the first of many contraptions that gave me a lot of pleasure. Solving problems creatively and simply had revealed itself to be one of the pleasures of research, and of life beyond research. Building contraptions did not arise from my research needs, but was already part of my life. I have always liked doing things with my hands, whether building shelters or carving wood in the Boy Scouts, repairing my 1946 Ford V8 convertible, building fine furniture, or constructing palm-thatched huts. Contraptions and gizmos were really an application of this tendency, but applied to my research they served it well. Each contraption was designed to solve a problem or answer a question, thus aiding my research. During the early years of my research, my equipment could be purchased for thousands of dollars, but I made later contraptions in my garage from wood, scraps, plastic, and salvage. These were the traits, preferences, and abilities that set me on my particular path of biological exploration, beginning with tenebrionid beetles and leading eventually to a wide interest in the natural history of ants. Almost by accident, I began my study of the subterranean architecture of ant nests, eventually